Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to be talking about Gibbs Free Energy, and this concept is super easy. It basically comes down to, does a chemical reaction occur or not? And it all comes down to the value of delta G, which is Gibbs Free Energy. So if delta G is a negative sign, what that means is that the reaction will occur. Okay. Now, books use some different vocabulary words. Okay. So my textbook that I use in my class uses the word spontaneous. And the word spontaneous simply means that the reaction will occur. Now, if you're in an AP chemistry class or maybe an introductory college class, sometimes they like to use this term thermodynamically favorable. Okay, so if something is thermodynamically favorable, that simply means the same thing as spontaneous, and spontaneous means the same thing as the reaction will occur. Now, if delta G is positive, it's the exact opposite, okay? That means the reaction will not occur, and therefore we're going to use the vocabulary word non-spontaneous, or saying that the reaction is thermodynamically unfavorable, okay? Those three things mean all the same thing. Basically, the reaction does not occur when delta G is positive. It does occur when it's negative, and then students come down to me and ask, hey, what happens if delta G is not positive or negative? What if delta G is 0? And what that means is that chemical reaction is in equilibrium, which means that the reaction will work in the forward and reverse direction at the same time. So this idea of equilibrium is a very special situation of which we will discuss kind of in some future units. Okay, so but right now, you just need to know that equilibrium means the reaction can work in both directions, and it can only happen when delta G is equal to 0. Most of the time, though, delta G is either going to be negative or positive, which means the reaction will occur or will not occur. Now, what equation do we use to calculate delta G? We use this equation, delta G is equal to delta H minus T delta S. Now, I want to do a quick reminder of what delta H is. Okay, delta H is the change in enthalpy. So this is an enthalpy term. Okay, and then delta S, okay, is an entropy term. So remember, entropy measures disorder. Okay, and then delta H measures kind of like the heat transfer. Okay, so this is where you get exo and endothermic reactions, and this is where you get things that are becoming disordered or more organized. And we just learned about delta S in a few videos before this one. Okay, so we're going to talk about the signs of delta H and delta S and how those signs will determine the sign of delta G. And of course, the sign of delta G tells us if the reaction will occur or not occur. And that's all there really is to Gibbs free energy. So there's going to be 4 situations that we're going to lay out. The first one is, what if delta H is negative and delta S is positive? What kind of sign would you get for delta G? And this is going to be the first of 4 scenarios that we're going to talk about in this video. Okay, so let's kind of come over to our equation. Okay, if delta H is negative, okay, so if we had a negative sign there, and of course we're going to subtract T delta S, and delta S is a positive sign, what kind of value would we get for delta G? That's kind of like the question that I'm asking. Now, some people might say, well, it depends if T is positive or negative. The T that's worked here has to be in the Kelvin scale. And when you're in the Kelvin scale, it's always a positive number. There's no such thing as a -1 or -2 Kelvin. The Kelvin scale is always positive. Okay, so really, we have a negative minus, and this whole term, since T is going to be positive, well, positive times a positive, that makes this whole term a positive, right? So a negative minus a positive, that's just going to give us a bigger negative, okay? So no matter what the temperature is, this sign is going to be negative. And what does negative mean? It means that it will occur. So reaction will occur, and it doesn't matter on temperature. So I'm going to put at all temperatures. Now, I want to kind of go into some of these details of what does it mean to have an enthalpy change that's negative, okay? What that means is that we have an exothermic reaction. So when this delta H is negative, it helps delta G being negative because of the relationship between the two. Okay, so exothermic reactions help delta G be negative, or basically saying helps the reaction become thermodynamically favorable, which means the reaction will occur. Now, what helps delta G become negative as well is a positive delta S. So when delta S is positive, that helps delta G being negative because of this minus sign. If delta S was minus, okay, well, when you minus a minus, that's really like making it positive, and making something positive means the reaction will not occur, okay? So when delta S is a positive because of this minus sign, it helps delta G have a minus sign. So what does a positive delta S mean to us, though? Like qualitatively, it means that the reaction is becoming disordered. So the most favorable reaction that we can have is when you have something that is exothermic, meaning releasing heat, and it's becoming really disorganized. If you have both of those factors, no matter their magnitude, 1 or 1 million, 1 or 1 million, this will end up being a negative sign, which means the reaction will occur. So the things that help chemical reactions occur is when you have exothermic reactions that create disorder, okay? So hopefully that really helps you out, because we're going to use that same kind of like knowledge to do the other scenarios, okay? And the second scenario is going to be the opposite of our first scenario. What happens if we have an endothermic reaction? Well, that doesn't really help a chemical reaction. And what if the system decreases its entropy, which means it's decreasing how disorderly it is, okay, which means it's kind of like organizing itself. Well, if you have those things, that's going to create a positive delta G. Let's take a look as to why. Okay, so if we plug in a positive for enthalpy, well, that's going to help delta G be positive. And if we minus it by T delta S, and this is a negative, right? Okay, remember this is going to be a positive right here. So this is just a larger negative, okay? So a positive minus a negative, that's going to give you a positive sign for delta G. And it doesn't matter the magnitude. It doesn't matter if this is 1 or 1 million. It doesn't matter if this is 1 or 1 million. You will always get a positive sign. When you take a positive and you subtract a negative, you will always get just a larger positive sign, which means the reaction will not, I'm going to underline that word not, occur, and the temperature doesn't matter. Okay, so that's at all temps. Now, our special situations is when you have the sign being exactly the same. Okay, so let's go to situation number 3. What happens if we have a negative sign and a negative sign? So this means an exothermic reaction that helps the chemical reaction take place, but we have a decrease in entropy, and that does not help the reaction take place. Let's take a look at what that would look like. So we're going to put in a negative sign here. So that helps, right? Minus T delta S, and that's going to be a negative sign, okay? What will delta G be here? Well, if we have a negative minus a negative, it kind of depends on the value of all of this, okay? For example, if we had negative 100 right here, but we minused, a negative, 500 here, well, negative 100 minus negative 500 would give me a positive number, okay? Well, what happens if it wasn't 500? What happens if it was just 50? Well, negative 100 minus negative 50 would give me a negative number. So as long as this stays small, and it's going to stay small because of the temperature being small, this is going to make a negative when the temperatures are lower. So this means that the reaction will occur, okay, at lower temperatures, but it will end up being positive at higher temperatures. So this means that when the signs are the same, that delta G is going to be temperature dependent, okay? So when they're both negative, the delta G will be negative at the lower temperatures, but positive at the higher temperatures. Because what temperature does, it starts to boost the entropy term, okay? So it just depends on what values you get from the enthalpy and the T delta S term. So let's kind of do a quick example of what I'm talking about here to make sure I bring this home. So we'll use some easy numbers. Let's say this is negative 100 and it's minus T, and let's say the delta S is equal to 50. Okay, we'll make it really, really easy numbers. Well, if this temperature is 0, basically this doesn't matter, and we're going to have a negative 100 when the temperature's at 0 K. Okay, if this is 1, okay, well, 1 times 50 is negative, we'll have the negative, sorry, this should be a negative here, sorry. That might make a little bit more sense, okay? So when this is a 1 here, this term is negative 50. Negative 100 minus negative 50 means that the reaction is still taking place at lower temperatures. But if I said the temperature was 10 here, well, negative 100 minus 10 times negative 500, or not negative 50 would be negative 500, and negative 100 minus a negative 500 would give me a positive sign. So there's always, at some temperature, it's going to switch from being what we call spontaneous, where the reaction will occur, to being non-spontaneous, where the reaction will not occur. Okay. Now, obviously, it's going to vary depending on what your value is for your enthalpy and what your value is for entropy. But when they're both negative, okay, it's going to be spontaneous at the lower temperature and non-spontaneous at the higher temperature. And what I always ask my students to do is just plug in 0 right here and see what you get for a sign at the lower temperatures. And then at the higher temperatures, go ahead and plug in like a super big number, like 1 million or something like that, and see if it's spontaneous at those higher temperatures. I think that's an easy way to kind of figure out this type of scenario, okay? Well, the last scenario is going to be, what if the signs are both positive? Okay, now remember, what this means is that you have an endothermic reaction, something that absorbs heat, but it's becoming disordered. Okay, what happens in that type of situation? Okay, well, if this is a positive, and I'm going to subtract T delta S, which is a positive, okay, so you got a positive minus a positive, it just comes down to their values, okay? So if this is 0, okay, if I plugged in a 0, basically this term is eliminated, and I'm going to have a delta G be positive, okay, at those lower temperatures. So at the lower temperatures, this reaction will not work because delta G is positive, okay? But as the temperature increases, okay, and let's say I have a positive here minus T with the positive here, right, kind of like what I had. If this temperature becomes 1 million, well, this term is going to be larger than this term. And if this is like 100 minus like 1 million, okay, you're going to end up with a negative number for your delta G. So at the higher temperatures, this reaction will work, okay? So to summarize this, when the signs are the same for both enthalpy and entropy, it's going to be temperature dependent, okay? And depending on if you have negatives or positives, something's going to happen at the lower temperature and something different is going to happen at the higher temperature, okay? The things that make chemical reactions thermodynamically favorable is when you have exothermic reactions. So this helps the reaction occur, okay? And when you create disorder. And if you have both of those things, no matter what, okay, the reaction will have a negative delta G. And remember, negative delta G means that the reaction will occur. So when they're the same sign, temperature dependent. If you have something that's exothermic and creates disorder, it will always happen no matter what. Of course, if you have the opposite, something that's endothermic, that decreases the disorder or increases the order, okay, that reaction never ever takes place. And those are the 4 situations that you can have, okay? I hope this information is helpful. In the next video, we're going to do some practice problems using this equation and then evaluating if our delta G is going to be either negative or positive or even 0 in the next video. And like I said, if you found this information helpful, please give it a like and subscribe. Leaving a comment always helps push this information out to other students that might be interested in learning chemistry.